Hello class, in this video I will be showing you how to find all zeros of a polynomial function and how to rewrite a polynomial function in completely factored form. Let's begin. In this example we want to find all zeros of g of x and rewrite g of x in completely factored form. The degree of g of x is 4, so by the fundamental theorem of algebra there are 4 complex zeros. I'm going to start by finding all of the rational zeros of g of x, and I'm going to do that using Decimus. I've gone ahead and graphed g of x in Decimus, and notice that the graph has 4 horizontal intercepts. And of the 4 horizontal intercepts, it looks like 2 of them are rational. There's a 0 at -3 and a 0 at -half. And we're going to use those 2 zeros to find the exact values of the other 2 zeros. So from Decimus, x is equal to -1/2 and x is equal to -3 are zeros. To find the other 2, I'm going to synthetic divide. And I'll start by synthetic dividing by -half. Bring down the 2. 2 times -half is -1. 13 minus 1 is 12. And I'm going to finish the synthetic division. And as expected, the remainder is 0 because -half is a 0 of g of x. Now I'm going to synthetic divide by -3. And I'm going to use these numbers that I just highlighted in red. Bring down the 2. 3 times -2 is -6. 12 minus 6 is 6. And I'm going to finish synthetic dividing. And again, the remainder is 0 because -3 is a 0 of g of x. The 2, 6, and -10 are coefficients of the polynomial 2x squared plus 6x minus 10. And this is a factor of g of x. So what I'm going to do is set that factor equal to 0 and solve for x. Since every one of these numbers is divisible by 2, I'm going to divide each term by 2. And now I'm going to use the quadratic formula to solve for x. So we have x is equal to -3 plus or minus the square root of 3 squared minus 4 times 1 times -5, all divided by 2 times 1. After performing all the arithmetic, you're going to have -3 plus or minus the square root of 29 divided by 2. So now we have all 4 zeros of g of x. The zeros are x is equal to -1/2, x is equal to -3, x is equal to -3 plus the square root of 29 divided by 2, and x is equal to -3 minus the square root of 29 divided by 2. So g of x can be written as a times x minus -1/2 times x minus -3 times x minus -3 plus the square root of 29 divided by 2 times x minus -3 minus the square root of 29 divided by 2. To find the value of a, we go back to the given polynomial. The lead coefficient is 2, which means a is going to equal 2. So we have g of x is equal to 2 times x plus 1/2 times x plus 3 times x minus a -3 plus a square root of 29 divided by 2 times x minus negative 3 minus the square root of 29 divided by 2. And we are done.